Plastics extrusion is a continuous process in which thermoplastic feedstock material in an extruder is transformed into a molten, viscous fluid using heat and mechanical shearing. This thermoplastic fluid is then forced through a die opening where it is shaped and cooled into solid form. These forms include bar and rod, tube and pipe, or profiles such as angles and other cross-sections, flat products such as sheet and plate, flexible film for bags and packaging, monofilaments, and wiring insulation. Thermoplastic feedstock is fed to the feed barrel from the hopper. Hoppers are typically vacuum-fed automatically, but may be filled manually. As the feedstock enters the feed barrel, it is driven forward by the rotation of the screw. The feedstock plasticizes or melts as the rotating screw drags it forward. This is referred to as drag flow. Drag flow causes the thermoplastic molecules to slide over each other, creating frictional heat, which melts the material. External heating bands provide additional heat to the feed barrel, bringing the material to its final temperature. Two of the principal plastic extrusion processes are profile extrusion and blown film extrusion. Profile extrusion is a horizontal process used to make long, continuous shapes having a constant cross-section or profile. The profile is extruded into a long horizontal cooling tank or trough filled with water. This water cools and solidifies the extruded plastic as it exits the die. At the end of the cooling tank, haul-off rolls pull the profile away from the die at a uniform controlled speed. As the profile is pulled through the haul-off rolls, a cutter shears it to the required length for further processing. Some profiles are difficult to extrude because of shrinkage and the flow characteristics of the plastic. Typically, generous internal and/or external corner radii are used to minimize these concerns. Additionally, some profile extrusions may also require inline sizing to achieve dimensional tolerances. The blown film extrusion process uses an extruder to pump molten plastic vertically up through a die having a 360-degree annular opening on its top. This produces a tubular film extrusion, which is subsequently filled with air. As a result, the tube expands out into a bubble, having a diameter larger than the diameter of the annular opening of the die. The tubular bubble cools as it is pulled up. When sufficiently cooled, the bubble is flattened within a collapsing frame. The flattened plastic is then pulled through a series of rolls, commonly referred to as nip rolls. Nip rolls help to maintain tension on the flattened plastic film as it is guided to a winder and wound onto a core for later use.